So once again, we're simplifying radical expressions, in this case, again involving multiplication. With part A, we're given 6 times the square root of 6x squared times 8 times the square root of 30x to the fourth. We're simply going to use brute force. We're going to pull out the constants first. So 6 times 8 times the square root of, let's just go ahead and combine these. 30 times 6 is 180. X squared times x to the fourth is x to the sixth. So what factors of 180 are perfect squares? If we look at the factors, we'd recognize that 36 times 5 equals 180. 36 is a perfect square, so this equals 6 times 8 times the square root of 36 x to the sixth. Since 6 is even, we'll take the square root of that, and we're left with 5. So that ends up being 6 times 8 is 48. 36 x to the sixth, square root of that is 6. And then 6 divided by 2, the square root of 36 is 6, and then the square root of x to the sixth is x cubed. And we're left with this 5 under the radical, so square root of 5. 48 times 6 is actually 288. X cubed. And all of that times the square root of 5. Similar process with part B. We have that this equals -4 times that negative, let's make it a -1. And then again, let's just multiply everything through. This time, let's do the prime factorization. So we have 12, that's 2 times 2 times 3. And 8 is 2 times 2 times 2. And then we'll go ahead and just multiply the y cubes. We'll make that y cubed times y cubed is y to the sixth. But we want perfect fourth roots. Forgot to put this index out there for the fourth root. So y to the sixth is the same thing as y to the fourth times y squared. And again, we did that because we want the fourth root of y to the fourth. So -4 times -1 is just 4. And then let's go ahead and we'll take care of these as we go. Let's break this up into two separate radicals. Fourth root of and fourth root of. So let's look for factors that appear 4 times. 1, 2, 3, 4 2s, so that's 2 to the fourth. That leaves us with 1, 2. So we've taken care of that one. Now we have a 3 under here still, but there's no perfect quadruple, perfect quad. So we're left with 2 times 3. The fourth root of y to the fourth, so we have y to the fourth underneath the fourth root, and we're left with y squared. So 4 times the fourth root of 2 to the fourth is 2. The fourth root of y to the fourth is y. And then we're left with what's under the radical on the right. 2 times 3 times y squared, that's 6y squared. And then multiplying the constants, we end up with 8y times the fourth root of 6y squared.